Imagine never having to wash a shirt stained with tomato sauce again. No washing machine, no soap, no scrubbing, just running water, and the stain simply lifts off. This isn't science fiction. A team of chemists in China just published, in a serious scientific journal, a fabric that does exactly that. And the reason it works is so strange it almost sounds wrong. They didn't make the fabric drier. They deliberately covered it with an invisible layer of water. Stick with me, because in a few minutes you're going to understand why this could change a task you do every week, your whole life, without ever questioning it. Stop for a second and think about how many times you did laundry this month. If you're like most people, that's dozens of cycles, just in your own home. Now multiply that by every household in your neighborhood, your city, the planet. Doing laundry is one of the most repeated household tasks in human history. It's so deeply woven into our daily life that we barely notice it anymore. Every washing machine cycle consumes treated water, electricity to heat and spin the drum, and detergent, a chemical product manufactured, packaged, and shipped just for this one purpose. And behind every wash cycle sits an entire chain: water treatment plants, power stations generating electricity, industries producing soap. A task that seems small, done at home, is actually held up by a massive infrastructure, one that most of us never stop to think about. That's exactly the blind spot that led a group of researchers to ask a simple question. What if the problem was never the machine or the soap, but the fabric itself? Here's what stays invisible in everyday life. Doing laundry carries an environmental cost that travels right along with the water going down the drain. According to the research published in Communications Chemistry, laundry consumes billions of liters of water every year worldwide and releases tons of detergent and microplastics back into nature. Microplastics, those tiny fibers that shed from synthetic fabrics with every wash cycle, too small for most ordinary treatment plants to fully filter out. They flow into rivers, into the ocean, and, according to various environmental studies, end up entering the food chain. In other words, the problem isn't just the bucket of water leaving your tap. It's what comes back, invisibly, into the environment afterward. And for decades, the industry's answer always pointed in the same direction: improve the soap. More concentrated detergents, more biodegradable ones, more efficient machines. Everyone trying to make the same recipe use a little less. Only nobody had tackled the more obvious question: why does dirt stick to fabric in the first place? That question had actually attracted scientists before. In 2018, researchers at RMIT University in Australia developed a fabric that cleaned itself using copper and silver nanostructures, materials known for absorbing light. When exposed to sunlight or even ordinary electric light, these nanostructures generated what the scientists called hot electrons, capable of breaking down organic residue stuck to the fiber. In testing, the self-cleaning process began after just 6 minutes of light exposure. It was a real breakthrough, but it depended on something nobody can control all the time: enough steady light, hitting the fabric directly. A shirt folded in a drawer or worn under a coat simply didn't get enough light for the effect to kick in. The wall became clear. It was possible to make a fabric react to light, but no one had managed to create a fabric that solved the problem without depending on such an unstable external condition. That's when the Chinese team behind the new study decided to abandon that entire line of thinking. Instead of asking, how do we make light clean the fabric, they asked a completely different question. What if, instead of trying to destroy dirt after it's already stuck, we simply prevented it from sticking in the first place? Not a fabric that reacts, a fabric that from the start never lets dirt get close to the fiber. Put that way, it sounds simple. But turning that idea into something real meant rethinking, at the molecular level, what actually happens on the surface of an ordinary fabric. According to researchers Chongling Cheng and Dayang Wang, the study's authors, the solution was to create something they named molecular water armor. Let me explain the mechanism with a simple image. Think of the surface of an ordinary fabric, cotton, silk, or polyester, as a dry, unprotected sponge. Oil, sauce, sweat, all of it finds open space to work its way between the fibers and stick. What the scientists did was spray onto the fabric alternating layers of polymers, long molecules, like microscopic threads, carrying electrical charges, one positive, one negative, stacked one on top of the other, like impossibly thin sheets. These layers form a nanometer-thin film, rich in a chemical structure called a sulfonate group. And here's the key part. Those groups strongly attract water molecules, organizing them into an ultra-thin, stable layer across the entire surface of the fabric. In other words, the fabric ends up permanently covered by an extremely thin layer of water, even when it feels dry to the touch. Picture it like a fogged-up car windshield in the rain. The water forms a continuous film that keeps anything else from touching the glass directly. It's basically the same thing, just at the molecular scale, and permanent. That water layer acts as a physical barrier between the fabric and any contaminant. Oil, sauce residue, ketchup, none of it can get through that liquid layer to reach the fiber. The dirt simply stays floating on the surface. And the practical result? A simple rinse with water, no detergent at all, is enough to wash the dirt away. In the tests described in the study, the coated fabrics matched or even outperformed the effectiveness of traditional soap-based washing. Worth pointing out an important distinction. This isn't the same thing as a waterproof fabric, the kind that just lets water slide off. There, the water slips away without actually cleaning anything. Here, the water film itself is what does the cleaning. Up to this point, this would already be a major discovery, a fabric that cleans itself with just water. But the study goes further, and this is where the impact really expands. First, the number that gives this video its title. According to the researchers, this technology could reduce the amount of water and electricity needed for laundry by more than 80%. That's not a small tweak, it's a reduction on the order of magnitude of what we currently spend on every machine cycle. Second, remember those microplastics I mentioned earlier? Analysis of the rinse water showed something unexpected. The polymer film itself retains microplastics, preventing them from being released into the environment along with the water. According to the author's estimates, this could reduce the ecological impact of laundry by more than 82% compared to a normal wash cycle. And there's a third layer, which might be the most surprising one. This coating also has antibacterial and antifungal properties. By preventing microorganisms, sweat, and dead skin cells from attaching to the fabric, it prevents odor and stops mold from forming during storage, even when a garment sits packed away for a long time. A simple soak in water would be enough to make the fabric feel fresh again, without resorting to harsh disinfectants. And it's not a fragile layer that disappears after the second wash. Early testing indicates the film keeps its effectiveness after more than 100 washes without changing the fabric's feel or breathability. Stop and think about what this means at scale. It's not just a pair of pants that's easier to clean. It's potentially an entire sector, water treatment and distribution for household use, being relieved of one of its biggest recurring demands. It's the textile industry getting a real, testable answer to the microplastics problem, which today is mostly handled with filters and stopgap policies. Before we continue, if you had the option today, would you swap your current clothes for garments with this coating, even knowing it's still in the testing phase? Drop your answer in the comments. I genuinely love to read what you think. And if this kind of discovery interests you, consider subscribing to the channel. There's a lot more like this coming. Now, the most important point in this video, and what separates a real discovery from an exaggerated promise. This technology is still at the proof of concept stage. That means scientists showed in the lab that the principle works, but that's very different from a finished product you can buy. The study itself is clear about the next steps still needed. The team still has to run tests with real consumers outside the controlled lab environment to confirm whether comfort and everyday practicality hold up. And before any possibility of commercialization, an independent safety and full life cycle analysis of the material will be required, meaning understanding what happens to this polymer over years of use and whether it's safe for prolonged contact with skin. It's also worth remembering, even in the best-case scenario, this kind of technology depends on an industrial process capable of applying it at massive scale, Spraying polymer layers onto billions of meters of fabric is a very different manufacturing challenge than doing it on a handful of lab samples. Cost, mass production feasibility, and safety regulation for new materials in contact with skin are steps that historically take years, sometimes decades, between a study's publication and a product reaching store shelves. So, no, this doesn't mean your washing machine is headed for the scrap heap next year. It means there is now real proof that it's possible to completely rethink how we deal with dirt on fabric, and that, on its own, is already significant. There's a bigger idea behind this study, one that goes beyond clean clothes. For pretty much all of human history, we've solved problems of dirt and hygiene by adding something: more soap, more hot water, more chemical product. This research proposes a different path. Not adding anything more, but redesigning the material itself so the problem simply doesn't happen. What if this same logic expanded into other parts of our everyday life? Kitchen surfaces that never build up grease, hospital uniforms that resist contamination on their own, public use fabrics, bus seats, airplane seats that barely need constant chemical sanitizing. None of that is guaranteed today. But the scientific foundation to start imagining it now exists, published, peer-reviewed, with identified authors and a clear path laid out for what still needs to be tested. And that leaves me with a genuine question for you. When we think about innovation, we usually picture robots, artificial intelligence, big, flashy things. But could the quieter changes, like rethinking a fabric from the ground up, sometimes be the ones that actually move the needle in people's real lives?
If this video made you look differently at a task you do every single day, drop a like, share what you think in the comments, and subscribe to the channel to follow along as I cover the next discoveries that could, little by little, change things we never imagined could change. See you in the next video.